All right, the topic for this video is subatomic particles. So what particles are found in the nucleus? What particles are there? Let's get to it. Here are the objectives. Pause and peruse if you wish. Okay, first up, electron. Location in orbitals outside the nucleus. The charge of an electron is negative. The mass of an electron, very small, it's about 9.109 times 10 to the negative 31 kilograms. It's about 2,000 times smaller than the mass of a proton. It was first discovered, remember, with cathode rays, that experiment done by J.J. Thomson. Next, we have proton. Location in the nucleus. The charge is positive. Its mass is about 1.673 times 10 to the negative 27 kilograms. Remember, electron was negative 31. So it's about 2,000 times larger than the mass of an electron. The number of protons is defined by the atomic number, and this determines the identity of an element. So the atomic number is the number of protons in the nucleus of an atom, and that determines what element it is. 1 proton, hydrogen. 2 protons, helium. 8 protons, oxygen. You determine the element by the number of protons. So the periodic table gives you the number of protons, the atomic number. So this is based on our reference table. You can see I have highlighted the section where it says atomic number. You find this key right at the top of your periodic table, so you don't have to remember it. So that means the atomic number of carbon is 6. So carbon has 6 protons in its nucleus. What is the atomic number of sulfur? And in case you don't know, sulfur symbol is S. 16. How many protons does oxygen have? 8. Its atomic number is 8. What element has 10 protons? Neon, Ne. How many protons are in a chlorine atom? 17. 17 is chlorine's atomic number. We are moving on to neutron. The location of a neutron is in the nucleus. Its charge is neutral. Its mass is about 1.675 times 10 to the negative 27 kilograms, very close to the mass of a proton. In summary, we say the charge of a proton is positive, neutron, no charge, neutral, electron is negative. So the charge of an electron and proton are equal and opposite of each other, okay? Now we talk about mass in terms of atomic mass unit. So remember those decimals? You don't have to remember them. What you do have to know is the relative mass. So in terms of atomic mass unit, proton has a mass of 1, a neutron has a mass of 1, and an electron, which is 2,000 times smaller, we give it a mass of 0. But remember, it doesn't actually have a mass of 0, but in terms of doing all the calculations, we'll consider it that. Protons and neutrons are found in the nucleus, and electrons are found in orbitals outside the nucleus. Just a note, a U, that symbol, atomic mass unit, where we get it from, it's 1/12 the mass of a carbon-12 atom. A carbon-12 atom has 6 protons and 6 neutrons in its nucleus. Divide that by 12, we get the relative mass that we consider for a proton and a neutron. Table O can help you remember some of those numbers and charges. A beta particle is an electron. So you see the number at the bottom is -1. That's the charge. If you find proton, it just has 1 at the bottom. So that's positive. A neutron has a 0 at the bottom. That's no charge. And then if you look at the top, that's mass. A beta particle or an electron has a 0. And a neutron and a proton both have 1. And we'll get into this in greater detail in a later lesson. Okay, let's talk about the nucleus. The location of the nucleus is in the center of an atom. It contains protons and neutrons. The charge of a nucleus is positive because of the protons. Remember, neutrons have no charge, so they don't contribute to the charge of the nucleus. And then nearly all of the mass of an atom is found in the nucleus, but only a small fraction of the atom's volume. So if we consider the radius of an atom as a whole, it's more than 10,000 times larger than the radius of its nucleus. So imagine a marble in the middle of a football stadium. That's relatively comparing the nucleus to the size of the atom. What about the stability of the nucleus? So there's Coulomb's law, which basically says the closer two charges are, the greater the force between them. So why do stable nuclei form? Because if we have two protons next to each other, they're going to want to repel each other. And I have more and more protons, they're going to want to repel each other with greater force. So why do stable nuclei actually form then? Why do we even have atoms? Well, there's a force called nuclear force, and that means protons and neutrons actually will attract each other. And it helps to overcome the electromagnetic force, the repulsion of two positives pushing each other away. So neutrons play a vital role in stabilizing the nucleus. There's only one atom that doesn't have to have a neutron in its nucleus, and that's hydrogen. So the neutrons, since they don't have a charge, they help to offset that electromagnetic force. The more and more protons there are in an atom's nucleus, the more and more neutrons I need for stability. If I have too many or too few neutrons, the nuclei or the nucleus is going to be unstable. So without neutrons for any atom except for one version of hydrogen, I need neutrons to help stabilize the nucleus. If you look at the atomic mass, it's the top left number on the periodic table. If the ratio of protons and neutrons is 1 to 1, the atomic mass will be roughly double the atomic number, which is true for helium, for boron, for carbon, for fluorine, for neon. But what do you notice as the atomic numbers get bigger? Okay, well, that ratio doesn't hold true. So if you look at silver, which is Ag, which has 47 protons, if it were a 1-to-1 ratio, then its atomic mass should be roughly double that, so 94, but it's not, it's 107. Okay, that means there's more neutrons than protons. So again, as the atomic size, the number of protons gets bigger, I need more neutrons to balance out that electromagnetic force. There's subatomic particles, the particles found in the nucleus and those outside in orbitals. So I hope you learned something new today.